All right, well, we're going to begin with the speed drill, your last speed drill of the school year. It is here, yes. So turn to the very last page of your speed drill and review exercise booklets. Turn to the very last page of your speed drill and review exercise booklets. So everything else away except for a pencil and your speed drill and review exercise booklet. And it's kind of a miscellaneous selection here. We've got addition, subtraction, multiplication, division. We've got some whole numbers listed out. We've also got some fractions. Quick refresher in case you needed it. Remember, to add or subtract fractions, class, you have to have a common denominator. Remember, to multiply fractions, we try to cancel numerator with denominator, but we can't use mixed numbers. They have to be improper fractions. And we never really divide, we multiply by the reciprocal. You've got 4 minutes for speed drill number 27, and you may begin. Seconds. Stop. All right, put your pencils away. Take a pen out. Pencils off your desks. Have out a pen. And go ahead and grade your own. These are 12 points each. 12 points each, because there are only 8 problems, right? So, finding a pen somewhere. Somewhere. Success. All right, going across the top row, working with the big numbers. First answer, 14,312. 14,312. The second one was 3,689. 3,000. That's 687, excuse me, I can't read. 3,687 is the correct answer. For the next one, 57,702. 57,702. And the division problem, 15. 15. Bottom row, working with fractions, 14 and 3/8. 14 and 3/8. For the next one, 3 and 4/9. 3 and 4/9. The next one was 9/11. 9/11. And the last one, 4 and 2/3. 4 and 2/3. All right, figure 12 points apiece. Yes, ma'am.
On the second one, how did you get that answer?
3,687?
Yeah.
Let's take a look real quick. All right, so we've got a 5,614 minus a 1,927, correct? So we can't do 4 minus 7, so we borrow, make this a 0, make that a 14. 14 minus 7 is 7. But we can't do 0 minus 2, so we borrow, make that a 10 minus 2 is 8. But we can't do 5 minus 9, so we borrow, make it a 15 minus 9 is 6. And a 4 minus 1 is 3. 3, 6, 8, 7. All right. Any other questions? Is that the only one you missed?
I missed the 5th one because obviously I don't know how to divide.
The 5th one?
Yeah, because...
The 5th one was an addition problem.
I mean, 1, 2, 3. Well, yeah. But the last part, I had 14 and 6/16, and then I reduced. You're supposed to divide by 2, and for some reason I put 2 instead of 3.
Well, you'll get some partial credit back if you had 14 and 6/16. Although I would say I wouldn't have gone with 16 as the common denominator. I'd have gone with 8. That way you can leave the 7/8 as it is and just change a half to 4/8.
Okay.
That would have been easier, wouldn't it? But, yeah, you had the answer, just need to reduce to the 3/8. Okay, any other questions, comments? All right, for now, take off all 12 points and I can go back and give whatever partial credit I decide on that one in particular. And then Lana doesn't know what happened on the other one. All right, so put the score in the score blank at the very bottom of the speed drill score page. Put your score at the bottom of the speed drill score page. We do have 2 review exercises that we still have left to do. We're going to talk about taxes, but we're going to save that for after the test, which is coming up tomorrow in our very next lesson. So part of our review is to go over the homework that you did over the weekend, page 543. Page 543. Go ahead and turn there in your textbooks now. And let's take a look at the 1 through 20 that you completed for homework. Page 543, numbers 1 through 20. Trying to give Lana a bit of a hard time about completing the homework because she turned in a homework pass instead. I should put on the fine print, cannot be used for math class, but forgot to work that in there, so I guess it's okay, Lana. All right, and Joshua, what a good student. He did his math homework. What great job, Josh. You're a good person.
We've got to use them before this Friday.
Yeah,
It's true.
that's happening.
Use them this week at the, Friday's the last day to use them, so you might as well. Anyway, all right, let's take a look at the answers here. Joshua, check your answers. Number 1 should be 361, just square the 19, 19 times itself. 169 is barely bigger than 144, so I would have tried 13 first, and it does indeed work. And then 729, well, you know it's smaller than 10, because 10 cubed is 1,000, and that's smaller than 1,000. Maybe try 9, and sure enough, that works. So 361, 13, and 9, the answers to 1 through 3.
The first one should be, oh wait, no, never mind.
All right. For number 4, the 4 and the 4th root cancel to give you just 15, bless you. The next one, you're going to divide the 6 by the 2 to get 5 cubed, which is 125. And for the last one, we divide the 32 by 8 to get x to the 4th. Questions on 4, 5, and 6.
On number 5, I just forgot to put 125.
You left it as 5 cubed? Okay, not wrong, but not simplified as it said in letter B. All right, number 7. What did you get for your answer, Josh?
70.
70, factor into 49 times 100, both of which are rational. 7 times 10 gives you 70. Number 8, when you factor, only one factor is going to be rational.
9.
9 times 11, so your answer,
3 times the square root of 11.
good, 3 times the square root of 11. Curious what you got on number 9.
10 times the square root of 8.
I wondered if you would get that, 10 times the square root of 8. Joshua, it's not wrong. It's just not finished, because you could further factor into
2 times 4.
where you could take the square root of the
4.
to get another
2.
times the 10 you had. Should have given you an answer of
20 times the square root of 2.
Yeah, I looked at that, I'm like, I bet he went 8 times 100. You know, you might have thought to go 400 times 2. In which case you would have gotten to 20 times the square root of 2 right away. But it's not wrong to do it that way. We just got to make sure we finish all the way through. Number 10, what'd you get?
7 times the square root of 3.
Yeah, when all else fails, I mean, maybe 49, and sure enough, we've seen that a few times. Here it was 49 times 3, so 7 times the square root of 3, our answer. Number 11, what'd you get?
3 times the square root of 15.
Good, factors in 9 times 15, that's the best you can do. So 3 times the square root of 15 is all we got. And then number 12, working with some letters in here.
M squared W squared times the square root of 24M.
All right, not wrong, but also not done. Because not only can we take care of the letters, we can do something with the number also. How might we factor the 24?
6. Oh.
Yeah, 6 times 4. So we should also, in addition to the m squared W squared, we should also have a 2. M squared W squared, and instead of a 24, we should have been left with a 6. And this would have been the correct answer there on number 12. So again, something to watch for on the test tomorrow is double check your answers and make sure there's nothing else you can do. In fact, that might be a good thing to do once you've finished the test, is go back and recheck your answers. Say, okay, is there anything else I can do? Can I check, can I reduce any further? Checking each of those. Number 13, Lana, you can do in your head.
8 times the square root of 13.
8 times the square root of 13. Number 14, it should be pretty obvious, Joshua, that it doesn't add. You can't simplify either of those. And number 15 on the surface, Lana, you can't add them. But you can factor the 40 into
4 times 10.
and the 90 into
9 times 10.
so that you can reduce these to get
2 times the square root of 10 plus 3 times the square root of 10, which gives you 5 times the square root.
5 times the square root of 10 is correct for number 15. Number 16, we had to subtract the 11, divide by 6, take the square roots. And what did you get for your answers, Joshua?
Yeah, it should be answers.
Uh-oh.
Which number?
Number 16, we get?
Positive, negative 2.
Positive, negative 2. And number 17, we should add the 1, divide by 2, take the square roots, or try to, but you can't take the square roots evenly, so we have to reduce the radical. What was your reduced answer on 17, Joshua?
2 times the square root of 12.
All right. Positive, negative 2 times the square root of 12. Of course, the positive, negative, something I'd already referenced with this at the end of the roots and, you know, answers. But we're also not quite done here, Josh.
You can't do 6 times, 3 times 4.
There we go, where I can take the square root of the
4
to get
2
times the positive, negative 2 gives me
positive, negative 4 times the square root of 12.
3. The 12 is gone now. Remember, we factored in 3 times 4. So positive, negative 4 times the square root of 3 was the best answer for number 17. Number 18 says a telephone pole that's 24 feet tall has a wire staked to the ground 7 feet away. How long is the wire? So here's telephone pole. I'm not sure why it's not straight up and down, but we'll fix that, okay? And there's a wire. So we have a 24-foot telephone pole. This is grass. And then 7 feet away is the guy wire. How long is the wire? What do we do to solve this, Joshua?
Find the hypotenuse using the Pythagorean theorem.
Good. Treat it like a right triangle, like it is, assuming the telephone pole's straight up and down. Okay, and use the Pythagorean theorem to find the hypotenuse C, and what did you get?
25. Positive, negative?
Well, not positive, negative. It is positive, 25 feet. 25 feet. Just don't forget the unit in the answer, because it didn't say how many feet is the wire, but how long, so want to make sure we include that unit. Number 19, they give you a triangle that, by the way, is a right triangle. How can I make sure it really is a right triangle, Lana?
You plug in the formula?
Okay, which one?
Pythagorean theorem?
Yeah, plug the numbers into the Pythagorean theorem and see if it's really true, right? It looks like a right triangle, but check and see, does 26 squared equal 10 squared plus 24 squared? And yeah, 676 does equal 100 plus 576, right? So we can check that easily enough. So it really is a right triangle. And so for angle A, they weren't asking that, Joshua. I was just mentioning if there were any question, we could find it. They wanted us to find the sine, cosine, and tangent of angle A. Now, sine, cosine, tangent, Lana, you did a better job than Joshua. How do we remember the ratios for sine, cosine, and tangent?
SOHCAHTOA.
All right, there we go, SOHCAHTOA. And how do we spell SOHCAHTOA, Joshua?
SOHCAHTOA.
There we go, SOHCAHTOA. And the class, let's say what it stands for. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And so for angle A specifically, I always find the opposite first, class. What's the opposite of angle A? 10. Obviously the hypotenuse is 26, and that means the adjacent is
5.
the adjacent is
24.
24. Once we know those sides, now we can find sine, cosine, tangent, and we can actually reduce all of these answers by 2. So Joshua, what was your answer for the sine of A?
5 to 13.
5 to 13. The cosine?
12 to 13.
Good. 12 to 13. And the tangent?
5 to 12.
5 to 12. Very good. Questions on sine, cosine, tangent? All right, and the number 20, Michael said his new computer monitor is exactly 12 inches tall, 20 inches wide, and has a diagonal of 24 inches. Could this be accurate? Why or why not? And Joshua, thoughts?
No.
Why not?
Because the hypotenuse doesn't equal the legs when you do the Pythagorean theorem.
All right, so by the way, y'all know when you buy a TV or computer monitor, it tells you when it says the size, it's always talking about the diagonal length, right? And so he's saying he has a 24-inch monitor, which is 12 by 20. Well, is that accurate? So to find out, we do what we mentioned a moment ago, plug it into the Pythagorean theorem. Question, does 24 squared equal 12 squared plus 20 squared? Well, what's 12 squared, class? 144. 20 squared, of course,
400.
400. And of course, we know 24 squared is 576. Does that add up?
No.
Not quite. Now, most commonly, I can do this on the calculator actually, real quick. Heresy. I just dropped a math book. Yeah, that's terrible.
544.
Yeah, it's actually 23.3 inch diagonal, if these numbers are accurate. Usually when you buy a computer monitor, by the way, if it says it's a 24 inch or a 24 inch TV, it's actually not 24, it's 23.8. Probably it's supposed to be 23.8, and he's a little off. It's not exactly 12 and not exactly 20. But anyway, no, those are not the correct measures because it doesn't work in the Pythagorean theorem. Assuming his computer monitor is a rectangle. Okay, we are making that assumption because every computer monitor that I know of is a rectangle or a curved rectangle. All right, questions on number 20. Any questions at all on the homework? Lana, first of all, you did not take time to do it. That's fine. You had the homework passed. Did you understand everything we talked through? And then Joshua, good to go? All right. Flip back, if you would, to page 541. Page 541. And we've been working through this review exercise. Just quick recap here. Basic roots, reducing radicals, using fractional exponents. Now, we reviewed it in the last lesson, if you want to go back and watch the YouTube video, but we didn't actually use fractional exponents here because we're too lazy. We worked with adding radicals in the last lesson. Picking up with numbers 45 to 50, go ahead and solve those 6 pure quadratic equations, sometimes called incomplete quadratic equations, because there's no first power. The book refers to them as pure quadratics. 45 to 50 at your seats. Here at the bottom of page 541. Have you used all your homework past this line, or do you have one left?
I have one.
So of the 2 you've used them both for my class. It's okay, I don't take it personally. Just wait till you graduate, see what your diploma looks like. Just kidding.
I'm sorry.
I'm picking on you, you're good.
I should have used some of mine.
You still have 4 more days.
You can use it for math.
Not for math, for other things, yeah.
Unless you wanted to do it for math.
We already plan on using it for that reading quiz, though.
Wow, Lonnie, you ended the year with a 96 overall average on all your speed drills put together. That's impressive.
Yeah.
You averaged in what?
Well, no, the averages were all so close that it was easy to average in my head.
Oh yeah. The last 2 were 88s because I missed like a few on the addition one. And then the one I just did, I only missed 1. I was just being dumb.
Joshua came on strong this quarter. Yeah, finished with an A for the quarter. Good.
Do I have any?
I'm talking about in the speed drills. Yeah, I already told you that.
Oh.
Well, yeah, you ended up with 96 for the quarter, but also 96 for the year. It was just really
Oh.
impressive that you did that well on the speed drills. Joshua. And good luck. Let's take a look at the answers here. Number 5, Josh, or 45. What did you get, Josh? Positive negative 5. Number 46. Lana?
Positive negative 8.
Positive negative 8. 47, Josh.
Positive negative 25.
Good. Positive negative 25. I will take a look at it in a minute. Number 48. Lana?
Positive negative 1.
Positive negative 1. Number 49.
Positive negative 2 times the square root of 5.
Good. Positive negative 2 times the square root of 5. And number 50, Lana.
Positive negative 4 times the square root of 2.
Good. Positive negative 4 times the square root of 2. Number 47, let's look at it real quick since there was a noise of surprise or consternation, I'm not sure which, that issued forth from a student a moment ago. And we have w squared over negative 5 plus 9 equals negative 116. Josh, what's the first thing we need to do?
Subtract 9 from both sides.
Right, it's negative 9 on both sides. That'll give us a w squared over negative 5 is equal to...
Negative 125.
Good, remember the signs are the same. Add and keep the sign to get negative 125. Lana, what will we need to do next?
Divide by the 5.
Ooh, it's already being divided. Remember, we always do the opposite. If it's being divided, we need to multiply both sides by
5. Negative.
negative 5. And that's important, by the way, because if it weren't a negative 5, you'd be trying to take the square root here in just a minute of a negative. Can you take the square root of a negative, class? No, that's an imaginary value. But here, by multiplying the negative 5, it gives us w squared equals a positive 625, and that square root actually comes out evenly to just positive negative 25. And you could try factoring it up and be like, well, I know there's a 25 in there. Let's see, 25 times, 25. Oh, so in other words, that's 25 squared, and the square root of 25 squared is just 25. And could do it potentially that way also. Questions on this one?
Spinning down again.
All right, any other questions on 45 to 50 that we needed to take a look at? All right, turn the page. And number 50 and 51 and 52, you're finding the missing side. 53 and 54, you're determining, is that really a right triangle? So go and do 51 to 54 now. They're on page 542. Let's see how we did on these. Number 51, what did you get for the length of the hypotenuse, Joshua? 15, good. 81 plus 144 equals 225. Take the square root, you get 15. Number 52, Lana, what did you get for the length of that leg? 12. 169, subtract away the 25 from both sides, gives 144. Take the square root for the leg to get 12. Number 53, is that a right triangle, Joshua? No, 361 does not equal 144 plus 225, but it's pretty close. That's 369. It's really close to being a right triangle, but not quite. How about number 54, Lana, yay or nay?
Yes.
Yay, it is verily a right triangle, because as we showed a moment ago, actually, 676 plus equals 576 plus 100. Look at number 55. Now, you're not going to have to do this for the quiz or test, but I just want to kind of throw this thought out there. You see those two red dots on 55? Mm-hmm. With your pencil, as best you can, try to draw a straight line between them. Try to join the 2 points with a straight line if you can. Now, what you see there, that line between the 2 points, is the distance between them. Does that make sense? The distance between 2 points is whatever straight line would be between them. Now, if you would, you see how the red dot in the bottom has a little gray line going through it? Trace on top of that gray line, if you would. Trace on top of the gray line that's going side to side. Look at the bottom red dot. There's a gray line going side to side through it horizontally. Trace that horizontal line.
Like all the way?
All the way across, yep. Now, you'll notice as well that the upper red dot also has gray lines going through it, but I want you to trace the vertical gray line that's going through the upper red dot. As you trace that gray line, you'll notice that the two gray lines intersect each other. And if you take those two intersecting perpendicular gray lines that you traced, and that slanty diagonal line that actually joins the points, you formed a right triangle. Now, I want you to count how many boxes down you would have to go. From the upper red dot, just count straight down the gray line. How many boxes down? How long is the vertical leg?
Like that.
So from the upper dot to the lower dot, count how many boxes down
12.
you have to go. Good, it's 12 boxes, right? Now count across here where you got the two crisscrossing lines, count how many boxes over, and Lana will tell us how many boxes across the lower leg is. 9 boxes. Now, look further up the page and tell me how long is the hypotenuse. If you look at the blue triangle at the top of the page, which Scott just did, yeah, that's how Scott's fast. He cheats. He looks at the blue triangle at the top of the page and says, we already did this once. 15 units. That's how you can find the distance between 2 points.
That's actually pretty simple.
It is, yeah. So it's a graphing concept, which is why it won't be on the test. It'll be X'd out, actually, on your test copy, but it's not hard to do, right? All right, if we have time, we'll come back and do 56 in just a little bit. But for now, I want you to do 57 and 58, a couple word problems that will involve right triangles in their solutions. 57 and 58.
Are these the picture ones again?
Yeah, you're going to want to draw a picture for these.
These are sometimes.
working on 57 and 58. Hayden and Glenn, I need you to come with me here in just a second. Do y'all feel strong today? Yes. I'm taking him. He's with me. So this is my box, and it is 66 centimeters tall, and it's 112 centimeters wide. And the question is, if you draw a stripe diagonally from corner to corner on the side of the box, what will be the length of the stripe? Now again, we're assuming that boxes are built with right angles, correct? How would I find the length of the stripe, class?
C squared equals A squared plus B.
Right, C squared equals A squared plus B squared. And now, you won't have one quite this nasty on the test tomorrow as far as huge numbers, but what did we find for 66 squared?
I don't have that, but I have the
What's the 112 squared? You did the big one first.
12,544.
Oh, I know.
12,544. All right, and then 66 squared?
4,356.
All right, and we'll add those to get, let's see, that's, wait a second. 16,900. Now, we know the square root of 169, don't we?
13.
13. And we know the square root of 100 is 10.
So it's 130.
130. So apparently it's 130 centimeters.
That's right.
All right, and so despite the big numbers, still able to work that through. Okay, questions on that? And the next one says, Mr. Harris rested a 13-foot ladder against the side of his house. This is house. That is ladder. It's 13 feet. That is Mr. Harris. He's about to fall off the ladder. And the question is, how far from the side of the house should the base of the ladder be to reach a height of exactly 12 feet? What do we need to do here, Lana?
Wait. Find the leg of the bottom one?
Good, we're finding the leg of the bottom one here. Now really the 12 feet is right here. So really we're actually finding
So basically like this? Like that's the triangle?
Right, the triangles here, the ladder, the side of the house, and the ground. And the question is how far along the ground should we stick out the ladder if it goes 12 feet up and is a measure of 13 feet itself. And so since we're finding a leg, right, we'd say 13 squared equals 12 squared plus b squared. What do we get for the leg along the ground? Again, so not adding, but subtracting. Anytime you find the leg, you end up subtracting the values.
So, 5?
5. 5 feet is how far out the base of the ladder would need to be. All right, questions on word problems, how to set up the pictures, how to solve it, all of that stuff. Questions? Joshua, good to go? All right, look at the next page here very quickly. We'll finish out with a quick trig review. SOHCAHTOA. Trigonometry is easy. Finding for angle A, the sine, cosine, tangent, and for angle D, the sine, cosine, and tangent. Take just a couple minutes to work these problems, and we'll look at the answers, and then we'll be done.
What page?
Top of the next page. Page 543.
Yeah.
I just said next page. I didn't really look at the page number. Too lazy. So I was gonna be, and then somebody I know had to go and ask what page it was on. Make me look. All that work. Oh. Let's take a look at 59, and we were finding the sine of angle A, and what did you get, Joshua?
21/35.
Yeah, but what can be divided out of 21 and 35?
Oh, 7.
A 7. In fact, if you look at all three lengths, what can be divided out? 7. My suggestion, divide it out on the triangle itself first. Does that make sense? And that would make life easier. Instead of finding 21 to 35 and then reducing, make all the sides 3, 4, and 5 respectively, and then it's easier to get the 3 to 5 for the sine of A. Then for the cosine, Lana, 4 to 5, and for the tangent, Joshua, 3 to 4. Let's do the same thing on the next triangle. It's got some bigger numbers this time, but as we look at it, 21, 75, and 72, and we're looking at the angle D. What can be divided out of 21, 72, and 75?
Nothing.
Look at the digits themselves. 7 and 5, 7 and 2, 2 and 1, 3. So if I take a 3 out of a 21, it gives me, of course, 7. Think money, divide 75 cents by 3, 25. And what about 72 divided by 3? 25 is 75, so 1 fewer 3 would be 72, that'd be 24. Or you could just divide by 3. So, looking at this angle D, what is the sine going to be, Lana? What sine?
24. So it's 24 to 25.
There we go. So Katoa, sine is opposite over hypotenuse, 24 to 25. What about the cosine, Lana? So Katoa, what's cosine?
So 7 to 25.
Good. Adjacent over hypotenuse. And then tangent, Joshua?
24 to 7.
24 to 7. Opposite over adjacent. Questions on that? All right, your test will be in our next lesson, lesson 172. You will not need a calculator. There's not some of the big scary numbers on there like we had in our review lesson today, so no calculators needed there, Scott. Then we will basically be starting our review after the exams. This is one class in which we won't have a lot of new material. Most classes, of course, you have some new material after test 11. This test 11 falls so late, we'll just go straight into our review. All right, so no written homework tonight other than just be ready. Be ready for the test. So look things over as needed to be ready. All right, when the bell rings, you are dismissed.